Yeah, hello grade 12s. We're doing one of the question papers. Question 2, paper 1, from one of the previous years, from my previous year question paper. It's a question on development. It's question 2. You are given the front view and top view of a transition piece showing a rectangle to a rectangle. Instruction: copy the given views of a transition piece, develop the surface of the transition piece. This one is a much easier one. We'll start with this one for those that did not get to understand the issues of true lengths of development in grade 11. We will start with this one. We'll go to a more complex one as we go along. So to redraw it, you redraw it as far to the left as possible. It said that the width is 60. There is 60. Here is the center, which is the middle, and then the height here it will be 40. It's 40. When I draw, I'll start with the top view because it is a point view. When I draw the top view, it's because it assists. In most cases, top view assists to draw, but I'll draw them simultaneously with the front view because some other dimension is easier to get to them from the front view. There we are. There's our ground line. Here is the base of the front view. So they say the front view here is 30. From the center I'll measure 15, 15. That's why I've drawn the center. Center is very important for me because now I know it's gonna be 15, 15. This 15 I can even take it from here. 30, 15, 15, 30. I can always project that to the required amount, to the required view. This height is 45. My 45 will be here. 45. The height here is 45 of the front view, but my front view will end there, very faintly here, very faintly there. It will end there. It's important that I draw these views simultaneously so that I don't keep on doing the same measurement more than once. The half of 40 is 20. There is my center here. So now this transition piece is 20 millimeters here on the top. It's 10, 10. Measure 10, 10. Three. I use my T-square once, and then you can always join here. One, join this side. The sooner you draw these views, the better. And then so that you can go on, because time is always not on your side. And then mine, it seems as if it is a little bit towards to the lower side. Let me check why. Is that 10, 10? My 10 is supposed to be right here. nothing wrong if you find your line not to be correct. It's a skill also to use a rubber or an eraser. You erase that line of yours, then you do it accurately. You like to draw these things as accurate as you can. Now, there we are. Let's complete this view for us, this top view. They say it's a transition piece because it changes. To transist is to change. But the bases are the same, but as it goes towards to the top, it tapers. The base size, it changes only in size. Now I start naming my corners. I will say here it's A, B, C, D. You will know why, so that I don't get confused. Here I say 1, 2, 3, 4. And then I know that this side is equals to that, and that one, and that one. I'm making these small circles just to differentiate my sides. So if I, now this is my ground line. This A1, oh, I name it also from the top. When you're looking at it from the front, from this direction, you are seeing D, and behind D there is A. You are seeing D, behind D there is A. Here you are seeing C, behind C there is B. And then behind 3 there is 2. Behind 4 there is 1. Now we are going to cut it open. A joint, they call it a seam, a joint where it has been cut joint. So we'll split it open here as we develop. We'll split it open. Let's look. Split it open at 1A. Here is A, here is 1. 1A is not parallel to the ground line. On this side is also not parallel. None of these from these views is A to 1 parallel to the ground line. If that is not the case, you will rotate, because for us to be able to get the true length, you must have a point view, or one side must be parallel to the ground line. So I will rotate my A. I use my compass, and then I rotate my A. I'll rotate my A. My A now has moved from here. It is now there. And I project it. I project it. So my A has been moved from here to there. There we are. It is the true length of what? Of this line that I've marked with a 0. That is my true length. Immediately, I like to, once I found a true length, I start developing. I know all these 4 lines, 1, 2, 3, 4, their true length is this one. Immediately I start. Now I'm starting with my development here. We will do it this way so that you're able to see. Now 1 will be here on the inside, 1. On the outside, as I rotate, on the outside there will be my A. So the true length of 1 to A is this one. It is the true length of 1 to A. 1 to A. A will be located here. And then from A I move to B. AB is parallel to the ground line. So this one is the true length. So since it is the true length, we take it as it is. It is the true length because it's parallel. On both sides we are seeing the true length, because on one side it is parallel to the ground line. Here is my ground line. On the opposite side we are seeing the true length. A is here. Now what do? We try to locate B. B will be somewhere here. We don't know where. but it must be linked with 1. So B must be linked with 1. B must be linked with 1. So I will construct this line. This line is from 1 to B. I'm forming a triangle. This method that I'm using, they call it a method of triangulation. I'm forming triangles. Mine, it seems not to be straight there up until there. So 1B is not parallel to the ground line. 1 to B, just to show you, it's not necessary for me to draw this line, just to show you, 1B is not parallel to the ground line. So I will have to rotate one of them and make it parallel to the ground line so that I am able to have a true length. So in this case, I will rotate B and make it parallel to the ground line. I'll rotate B. I may rotate B from this side, or I rotate B from that side. It's up to you. Okay, in my case, which one must I go for? I'm still thinking. Either one would be cool, would be fine. Now I'm rotating B from here. I'm making it be parallel to the ground line. So as B is now parallel to the ground line, I will project that. Now B has moved. Now B is here. So the true length of that is this one. It is the true length, this one. It is the true length of this line. This line I'll just mark it with 1, Roman figure 1. It will be that line. So for 1B, here is that true length. For 1B, there is 1B. Now 1B. Here is my B now. Now 1B. Here is the triangle that I have formed. It's a bit faint because it's constructed 1B. But where it has been cut 1A, A1 solid, and then A to B is solid. A to B is solid. Now, from 1 now I must move to 2. 1 to 2 is parallel to the ground line. This is the true length. It is parallel to the ground line. That is the true length. 1 to 2 is the true length. From 1 to 2 is here. 1 to 2. I'm forming another triangle. 1, 2B, or 1B2 is a triangle. Now from 1 to 2. Now I must move from B to 2. From B to 2, the true length is that one. That one is that one. We take it from there. Its true length is there. The true length of this line is that one. From B to 2. So you will have your 2 being here, and then from 1 to 2, 1 to 2, 2 to B, it's a solid line. That is my 2 here. And then now I move from B to C, B to C. B and C, it's a point view. Once you have a point view, just like this pen, when you see this point A and B. This is B and A. So you see them at the same point, which means on the other side you are seeing the true length. So BC is the true length because on this side you have a point view. BC is the true length. BC, it is the true length. There is C somewhere here. Now I must now move from 2 to C. I must link with 2. I will make my construction. Must link with 2. Here is my construction. Now from 2 to C, this one I will indicate with 2, Roman figure 2. This line is not parallel to the ground line. Where is 2? Here is 2. 2 to C is not parallel to the ground line. So what do I do then? I will rotate 1. In this case, I prefer to rotate C. On this one, I will rotate C. If I rotate C, this is what I do when I'm rotating C. I will rotate C. C now is going to be here, parallel to the ground line. And then I project. I've rotated C. C is now parallel to the ground line. It's no longer here, it is there. 2C. That is the true length of 2C. This is the true length of this line. That is the true length of that line. Now, from 2 to C, this triangle B2C. From 2 to C, this true length there is there. 2 to C. There we are. That will be from 2 to C. That will be the true length. There is my C. From 2 to C, this is a constructed line. There is my constructed line. Now I must move from 2 to 3. 2 and 3 point view, one behind another. This is the true length. 2 to 3. This is the true length. 2 to 3. 2 to 3 is the 3 is somewhere here. So now I must move from C to 3. C to 3 is this one. Here is its true length, is that one. C to 3. C to 3. Wait a minute. Yeah, C to 3 is that one. The one that is marked 0. C to 3. From C, you see now how these triangles help me to establish the points where they join. That will be my 3, and then 3C, C to 3, it's a solid line. Now I must move from C to D. C to D. From C to D, parallel to the ground line. C to D is a true length. C to D. C to D is a true length. C to D is a true length. And then now I must move now from 3 to D. I will form a triangle. From 3 to D. I'll form that triangle from 3 to D. This triangle, I'll form this line, I'll construct this line, so I will have this triangle, 3DC. Now this line, you will agree with me, it is the same as that one. It is the same, but on the opposite end. So the true length from there is the true length for this one. Where is the true length here? The true length is here. Where is the true length? Which is from 3 to D. From 3 to D, it will be the true length. So my D will be here. From 3 to D. From there. 3 to D is constructed. 3 to D. Constructed. And then from 3 to 4, 3 to 4, that is the true length. 3 to 4, that's the true length. From 3 to 4 is the true length. And then it will be now from D to 4. Where is D to 4? D to 4, that true length width is 0. D to 4, I already have it there. D to 4. Now it will be D to 4. So my 4 is here. This is my 4. D to 4 is a solid line here. And then I will move now from D to A. D to A point view, true length. D to 4 from D to A, sorry. D to A. D to A. And then now it must be from 4 now to A. 4 to A. I construct 4 to A. This one, you can agree with me, this will have the same true length, which is this one. This true length, I'm taking the true length there, which is now from 4 to A. 4 to A is that one. Now it's 4 from 4 to A. A is located here. Join now there. And then this line has been constructed, it's fainter. And then now that is my A. I must now move from A to 1. A to 1 is that one. A to 1 is this. A to 1 is this. A to 1. A to 1, 1 will be somewhere here. So now it's 4 to 1. Point view. 1 and 4 is a point view. Here you're seeing the true length. 1 to 4. 1 to 4, it's there. So that would be my one here. It will look like this. Started at 1, 1A, we ended 1A. We have the development of our transition piece. Because we were explaining you, it must take you around 15 to 20 minutes if you are used, because this one is much easier. Thank you for watching. See you in the next video.